Hello, Mr. Luang. This is the first video for my assignment. So for this first one, here's the problem. You can pause and read it. But before that, let me show you the video where I got this from.
Assertive. There. Completing 2 somersaults as she passes the 10-meter platform.
Okay, so that was the video of the Olympic diver performing a dive. And yeah, just so you know, this is a slow motion of her dive, so it's not an accurate depiction of how long it took her to reach the water. Oh yeah, here's the problem again if you need to pause it and read it. Okay, now for my part A, I'm going to ask, given how Hong Chen's moment of inertia changes, how does this affect her angular momentum as she falls? Explain your reasoning. So her angular momentum is going to stay the same because even though her moment of inertia changes from the radius, because she untucks and tucks her body, that means her radius will increase after she untucks her body. Her angular momentum will still stay the same because here I W equals IWF. And that's according to the principle that angular momentum initially equals final angular momentum. So if the angular moment or moment of inertia decreases, if the moment of inertia increases, then wait, hold on. If the moment of inertia increases, then the the angular velocity would decrease. So then, the decrease in angular velocity makes up for the increase in moment of inertia, which is why the final angular momentum will still be the same as the initial angular momentum. And then part B is, how long does it take for Hong Chen to complete her dive before hitting the water? So this is a free fall problem, so I can just do delta y equals VIY t plus 1/2. Since there's no friction, I'm just going to use G. And initially she is at rest. So then, and then she is also on a 10-meter platform. So then her total distance will be 10. And then 1/2, 9.8 t squared. Her time will be 10 divided by 4.9 t squared. Okay, her time will be 1.43 seconds. Okay, derive an expression to find the final velocity immediately before she hits the water using the law of conservation of energy, height, and other physical constants as necessary. So I know initially there's PE, and then after PE will equal to KE rotational when she tucked her body when she tucked her body in and acting as like a sphere. There's rotational energy plus kinetic linear energy. And I know mgh equals 1/2 I plus 1/2 mv squared. And then the moment of inertia for a sphere is 2/5 mr squared. And then we know that the angular velocity can be changed to v squared over r squared plus 1/2 mv squared. And then the R's cancel out, so we're just left with GH. So then that become 10, 2, 10, 5. The M's cancel out. Okay, and that is the final how I derived an expression for the final velocity before she hits the water. And then using the expression above, find the total kinetic, linear, or translational kinetic energy before she hits the water. So then I would just plug that back into the kinetic energy linear equation. So then the square root and the square cancels out. Oh yeah, that's VF. I gotta write that. Okay. Anyways. That cancels out, and then I just plug in all the values. She weighs 45, and then 10. Okay, so then my answer will be 3150 joules exactly. Now part E asks for what is the total distance Hong Chen covered while she was somersaulting? And this is a picture I drew beforehand just like to make everything quicker. So this is her on a 10 meters platform, and then that's her when she's rotating right here, and this is her when linear, just so I can picture it better. And during this period of rotating, she did 3.5 somersaults, which is basically 3.5 revolutions. And I know that in 3 revs, in each rev there's 2 pi rad, and then plus pi, because 1/2 of a rev is pi radians. So then you get 7 pi, which is equal to around 7 pi equals to 22 rad. And then I know I can use that because that's the angular displacement. So then I can put that into the equation for distance using angular displacement. So then I also know radius when she was somersaulting was 30 centimeters. So that's, here I can convert it. So then I just plug that radius back in here. So her distance will be 6.6 meters. Okay, that's all. Thank you, Mr.